JE YouTube channel. I welcome you all to this another lecture in the mixed question marathon series, where for RRB JE 2024, this game changer series, we have taken, we are providing you some important questions through our sessions. Okay, so welcome to another lecture. I hope everyone is doing fine, and your preparation for RRB JE exam is going well with our practice sessions. So in today's practice session of RRB JE and also CBT2 of SSC JE, I will be taking few questions that will be from thermodynamics, applied thermodynamics and fluid mechanics subject. So just request everyone to quickly join me for this session. I'm just waiting for everyone to join the session. I guess I have shared this session in my Telegram groups, and hopefully there will be some students just in few seconds live in the session. So waiting for everyone to join the session. Currently I can see I think 2 or 3 students are live. It's a very low number, but expecting you all to quickly join me for this session, and let's begin solving some important questions on mechanical engineering. Hello Neeraj, good evening, how are you? Have you cracked SSC JE CBT1? Are you preparing for SSC JE CBT2 or RRB JE CBT2? So if you are preparing for SSC JE CBT2, then your focus should be on thermodynamics, applied thermodynamics and FM subject, because they have very high weightage for SSC JE. And this session will be useful for SSC JE as well as RRB JE. Hi MS, good evening, welcome to the session. So good evening my friends, welcome. Okay, yes, SSC JE, okay, that's great Neeraj, and congratulations for clearing SSC JE CBT1. Okay, so I can see right now we have 4 students. I want to tell you all a very important thing, that this YouTube channel was started in the month of August, and you will be surprised to know that, or shocked to know that, even after 1 month, more than 1 month, our YouTube channel is falling short of 1000 subscribers by 47 students. So we want 47 more students in order to get 1000 subscribers, which is, although I believe that till now 1000 subscribers should have been crossed, but still 47 are left. I request everyone, see, I don't want any kind of, I don't want to, just increase subscribers just for the sake of increasing it. I want all of you to share this session to all the students who are preparing for the exam. They can come and they can subscribe to this channel. Okay, also those who have already joined, then please do not forget to like and share the session. Okay, also subscribe this channel and press the bell icon. Okay, you are also for SSC JE CBT. Very good, congratulations MS, and all the very best. Just follow this session. I promise you, with the kind of questions I am taking for this session, see, my subjects of thermodynamics, applied thermodynamics and FM, for SSC JE they have the highest weightage, more than 80%. So I promise you one thing, that if you continuously follow this session, you will definitely, because I'm not following any kind of boundaries. I am taking all the sort of questions. Even if it requires gate level questions which can be asked in the exam, I am taking that. Even if it requires engineering services level questions, I am taking for your class. Even if it requires any level of questions that can come in SSC JE CBT2 or RRB JE CBT2, I am taking those questions for your session. I promise you that if you guys follow this session, so with the help of the concept I am teaching and the questions I am teaching in the class, you will definitely get benefited. That's a promise. So this is my introduction. My name is Vikas Sir, and that is all the information you can see about the professional teaching career and subject that I have taught or will be teaching you. Okay, so all this information you can see here. One more thing, as you can see, that the result of scholarship test has been announced, and those who have got scholarship up to 90% and up to 50%, then you can It's time for celebration because we have got great discount on our courses. Prepare with that. Hi Sagar, good evening. And also, it's a request to join our Telegram of Mechanical. Resultant AJ Mechanical is a Telegram for Mechanical. Please join it so that you don't miss any PDF and sessions link. Coming to the first question, which of the following statement? Which one of the following statement is correct? During adiabatic charging of an ideal gas into an empty cylinder from a supply main. So you can see our backend team is also sharing some details with you guys regarding our Telegram groups, okay, for mechanical and civil. So if you are from mechanical, directly just click on that link and you can join our Telegram channel. If you are from also, if you are having any query regarding any courses, you can just call on these numbers. Now, what is this case? So we are having a supply main, and this is the supply main. From this supply main, an ideal gas is getting filled into a here is a wall. It is getting filled into a cylinder, and that cylinder is empty cylinder. This is an empty cylinder. First of all, it is empty cylinder. And this is also adiabatic charging. What is the meaning of adiabatic? That means this cylinder is not just empty, it is insulated. It is also insulated, my friends. That is, there is no chance of heat transfer. What will be the answer? I don't want all of you to just, remember the answer just for the sake of remembering it, that okay, रट लेते हैं, चलो इसका आंसर ये होगा या ये होगा. Understand the concept. First of all, if you remember when we study for SSCG, CBT1 or many times I have told you that this is a case of unsteady flow, where there is a charging of a cylinder and that cylinder is insulated and that cylinder is empty. That charging is done with the help of a gas. Sometimes they ask you what is the final temperature of the gas in the cylinder. You will say it is gamma times of initial temperature. It is that particular case, remember? But the question is, this result that final temperature is equal to gamma times initial temperature, this result comes how? How you get this result? So there is a complete equation and analysis done. I don't want you to follow that analysis, but the analysis is that the specific enthalpy of the gas in the supply main. Supply main means this. The specific enthalpy of the gas in the supply main is equal to specific internal energy of the gas in the cylinder. Specific internal energy. When you solve this equation, specific enthalpy in the supply main H1 is equal to specific internal energy. When you solve this, specific enthalpy is equal to Cp into T1. And what is this? U2, that is Cv into T2. So what will be T2? This will be Cp by C1 into T1, or T2 will be equal to gamma times of T1. So the result that you get, that final temperature is equal to gamma times initial temperature, actually that whole study comes from this equation, option number B. Okay, so I have always told you that remember this equation whenever a question comes in the exam, that there is a charging of a tank which is insulated and evacuated. You have to find the final temperature. Always remember this. But how you get this equation, that final temperature is gamma times initial temperature, that actually you get from an analysis done on the unsteady flow, okay, by applying the equation for unsteady flow in an open system. From that, in the end, you get this result, that enthalpy in the supply main is equal to final internal energy. If you solve this, you will get this result. Next, consider the following statements. Both auto and diesel cycles are special cases of dual combustion cycle. Both auto and diesel cycle are special cases of dual combustion. Okay. Combustion process in the IC engine is neither fully constant volume nor fully constant pressure. Combustion process in the ideal cycle is replaced by heat addition from internal source in closed cycle. Exhaust process is replaced by heat rejection in the ideal cycle. What is the meaning of ideal cycle here? So meaning of ideal cycle here is air standard cycle. Actually, they are talking about air standard cycle. Okay. In the air standard cycle, what assumptions we follow? We follow that the open cycle is treated as closed cycle. Yes. And what's the meaning of this thing? Open cycle is treated as closed cycle. That means here in the open cycle, normally in the IC engine, the cycle is open where suction and exhaust will take place. Suction exhaust will be there, and the heat addition and heat rejection will be with the help will be external. Okay. While in the closed cycle, whatever point is written here, exhaust process replaced by heat rejection, correct. Combustion process is replaced by heat addition from internal source, correct. So 3 and 4 point is absolutely correct here. 3 and 4 point is correct. What about the first and second point? Let's come to that. Combustion process in the IC engine is neither fully constant volume nor fully constant. Is it so? What is the meaning of combustion? Combustion means heat addition. In the Otto cycle, heat addition is at constant volume. In diesel, it is at constant pressure. So this statement is not correct. Okay. This statement is not correct. Both Otto and diesel are special cases of dual combustion. No, they are not a special case of dual combustion. Actually, dual combustion is a special case. Okay, so this is also not correct. The answer will be option B, 3 and 4. Here, only option B, 3 and 4 is correct. Because Otto and diesel are not a special case of dual. Actually, if you have any idea that when dual cycle was given after Otto and diesel. So it's very simple. पहले मुर्गी आया कि पहले अंडा आया, ये स्टोरी में नहीं घूमना है अपने को, right? So it's very simple that firstly Otto and diesel cycle came, and then two people known as Sabatier and Tinkler, they thought that why not combine the process of heat addition of the Otto and diesel in a cycle, and they combined it and they name it as dual combustion cycle. So actually dual combustion cycle is a special case of Otto and diesel. They combine the heat addition process of the Otto and diesel in the dual. Okay, so this is not correct. Next question. In refrigeration plant works on a refrigerator plant works on ideal vapor compression refrigeration cycle. The mass flow of the refrigerant is 0.035 kg per second and refrigeration effect is 110. What is the refrigeration capacity of the plant in ton of refrigeration? Understood the question? Questions understood, everyone? All right. If it is understood, what is being asked in this question? They are asking the refrigeration capacity, but not in kilowatt. They are asking the refrigeration capacity in, generally their refrigeration capacity is in kilowatt. How to find in tons of refrigeration? Divide by 3.5, you will get this value in tons of refrigeration. Because 1 ton refrigeration is equal to 3.5 kilowatt. Now, firstly, we need to find the refrigeration capacity in kilowatt. How to find that? Refrigeration capacity is equal to mass flow rate into refrigeration effect. So this is 0.035, which is mass flow rate, into 110. You will get the value of refrigeration capacity in kilowatt. Now then you divide it by 3.5, you will get the answer. Okay. Firstly, you need to understand why we need to find this in tons of refrigeration, because they are asking it in tons of refrigeration. So this will be 3.85 divided by 3.85. If you divide by 3.5, you will get this as 1.1 ton of refrigeration. Are you all getting this? All right. Next question. A working steam power plant has following data. Turbine work is given 970. Pump work is given, which is equal to Also, it's a request to everyone, to all the mechanical engineering students of India following our YouTube session. Although that this number is quite large number, 5 students have liked the session, 5 have joined. Sometimes I feel like that कि इतने लोगों का मैं क्या करूँगा यार, इतने लोगों को नॉलेज दे रहा हूँ. I feel so much lucky. I am teaching 5 those students who are going to crack SSC, JE, CBT2 or RRB JE exam. So I'm lucky that at least out of the 140 crore population, and out of from that, let's say 1.5 lakh students have filled the form in SSC, JE. At least 5 lakh may have filled for RRB JE, and from that at least 5 students are coming in the session. I'm so much happy, and those 5 will be selected from Resultant. You 5 will be selected, I promise you that. आपका सिलेक्शन पक्का है. पंप वर्क इज इक्वल टू 2 किलोजूल पर kg. Heat input in the boiler is 2980. Well, this question may look well, it's an easy question, because steam power plant works in a cycle, right? Works in a cycle. That cycle is Rankine cycle, and for a cycle, net heat is equal to net work. What is net heat? It is heat supplied minus heat rejected. What is net work? Turbine work minus pump work. Simple. Sometimes you have to simply follow a simple formula, you will get the answer. Heat supplied in this is 2980. Heat rejected you have to get. Turbine work is 970, pump work is 2. Solve it. I think most of you have already solved, and you are getting answer as 2012. Should I trust you or should I solve on my own? Because as you know, I have a bad habit of not solving the questions before coming in the class. I solve the question instantly. Okay, so I have trusted you, but if any student see recorded, and if they will say sir has done some mistake, then they will write in the comment box. So I don't want that. I have verified it. It is 2012. Next. A spark ignition engine working on Otto cycle has a cylinder diameter of 200 mm and a stroke of 280 mm. The clearance volume is 1760 centimeter cube. What is the compression ratio of the engine? Compression ratio of the engine, you know that compression ratio is 1 plus sept volume by clearance volume, right? Simple formula. Clearance volume is given. If you get the value of sept volume, you will get the compression ratio. Okay, so what is sept volume? Sept volume is equal to pi by 4 d square into L. D is the diameter here, bore, and stroke length is given 280. Because they have given this value in centimeter, it will be great if you convert this into centimeter. So this will be 20 centimeter and this will be 28 centimeter. So pi by 4 is directly 0.7854 into d square, that is 20 square, into L, that is 28. Solve it. You will get this sept volume in centimeter cube. Put it here, you will get the answer. Okay, MS is getting 5.997. Okay, बाकी भी solve करो. चलो सभी लोग. Yes, everyone, please solve it. You will get this as 8796.48. 1 plus 8796.48 divided by 1760. What is the value you are getting? Yes, everyone. See, I'm also trying to solve in the class. 5.998, that is 6. Now this can be approximated to 6, right? मैं तो सोच रहा हूँ जब सारे बच्चे रिकॉर्डेड ही देखते हैं ना, एक दिन में एटलीस्ट 100 बच्चे देख लेते हैं रिकॉर्डेड. सोच रहा हूँ रिकॉर्डिंग ही कर दिया करूँ हर क्लास की. क्या लाइव सेशन करना, रिकॉर्डिंग करके बढ़िया प्रीमियर करवाता हूँ. कितना बढ़िया रहेगा, है ना? Air at 27 degrees Celsius and 100 kilopascal enters in a steady flow to a nozzle at a velocity of 100 meter per second. If the inlet area of the nozzle is 0.5 meter square, what is the mass flow rate through the system? Air at 27 degrees Celsius. So mass flow rate, how to find the mass flow rate? Mass flow rate is equal to density into area into velocity. This is the formula of mass flow rate. Now in this question they have given the area, they have given the velocity. Do you know density? Density into area is 0.5, velocity is 100. But you don't know the value of density. How to get the density? Density, you know that ideal gas, air can be treated as ideal gas, and ideal gas equation is PV is equal to mRT. This will be P is equal to M by V into RT. M by V is density. So density will be equal to pressure divided by R into T. So pressure is equal to 100 kilopascal, 100 kilopascal. R is 0.287. Temperature is 300 Kelvin. This will be 300 Kelvin. Okay. Why this is 0.287? Because R is equal to 0.287 kilojoule per kg Kelvin. If it is not given, the question, you can always put R as this, Cp as 1.005 and Cv as 0.718 and gamma as 1.4. If nothing is given about the air or ideal gas, you can put these values. From here you will get density, multiply density here, you will get mass flow rate. Come on. Yes, everyone. Have you followed the same approach? See, I have a bad habit that I start solving question as soon as I see the question, but I think I should give you some time so that I should see that whether you are following the right approach or not, or you are just simply copying my approach, because you should know how to use your brain. If you don't use your brain, so this will be 1.16 into 0.5 into 100, which is 58 kg per second. The reason is, I think I should give you some time and I should check, okay, what answer you are giving, because I want to see whether you are actually using your brain or not, right? Because as soon as I see, for example, I will see this question, I will start solving. I should wait for some time, right? Okay, I will be waiting. Reason is, I just want to see that when you see a question, what approach you actually follow, right? And I request everyone, don't just copy and paste that if one student is giving option C or option B, then you also give the same answer. Use your approach, okay? If you are using your approach and getting the same answer, that's fine, but don't copy. Now see this question. A large diesel engine runs on a stroke cycle. Stroke cycle is written, but which stroke cycle is not written? 4 or 2 stroke? So question is 2 or 4. It's not given. Now that has to be checked by me. Let me check. As if now you can assume 4 stroke and solve it. I will tell you whether it is 2 or 4 stroke in few seconds. Okay. अभी के लिए आप लोग इसको 4 stroke मान के solve करिए. Consider it as, okay, yeah, 4 stroke. As you can see, I can see that this question came in ISRO and ISRO exam. Yeah, 4 stroke. So, all right. Consider this as 4 stroke, okay? No. I'm telling you this is 4 stroke. Maybe it is missing, but it is 4 stroke. So how to solve this question? 250. Renault is getting 250. Okay, let me just for now. I I'm marking Reynolds as the answer as final answer. Okay, so I will not be giving you much time to wait. I will be solving this question. If you remember, there is a formula for finding indicated power. What was that formula? It is mean effective pressure into PLAN K by 60. And if they are asking the answer in kilowatt, it will be 1000. This was the formula that we used to find the indicate power. Now question is, why I am thinking about this formula? Because in this question, see what is given. RPM is given. Displacement means, what is displacement volume? That means displacement volume here is 25 liters. That is A into L is given. This is already given. A into L, which is pi by 4 d square into L. This is already given 25 liter, or it is also stroke volume. This is displacement volume or stroke volume or displacement volume is given in the question. Now you will say, sir, what are you saying? Why are you applying the formula of indicate power? Because in this question they have given brake mean effective pressure, they have given displacement volume, they have given, so whatever data has been given, based on that we will be using this formula. Okay, so brake power will be, it is brake mean effective pressure into A into L into N. Now this is 4 stroke. For 4 stroke this will be N by 2, 60 into 1000. Just put all the values. This is 0.6 mega Newton. This is M, mega hoga. This will be mega Newton. So let me again verify it. Mega or milli? Megapascal. Yeah, it is megapascal. So this will be 10 to the power 3 Pascal into, this is 25 liter. In meter cube, this will be 25 10 power minus 3 meter cube into 2000 divided by 2 into 60 into 1000. Solve it, you will get 250 kilowatt. Are you all getting this? Okay, this is mega M. Clear? Sometimes we have to, and here these two values are just given to confuse you. This is just an additional data. The data which is given here, this is called as additional data, which is not required for solving the question. If you see some, and this question is not engineering service, this is ISRO question. This question came in ISRO 2015. Sometimes you will find this kind of question where some data is given just to confuse you. We don't need to put that data. We don't require, that data is not required, but it is given. A 10 kg solid at 100 degrees Celsius with a specific heat of 0.8 is immersed in 40 kg of 20 degrees Celsius liquid with a specific heat of 4. Estimate the temperature after a long time if the container is insulated. So actually what is being given in this question, that there is a tank which is insulated. There is an insulated tank, and in that tank there is some liquid, and in that liquid there is some solid. That solid is kept in the liquid. Okay, you have to tell that if the solid is kept in this liquid for a long time, then what will be the temperature after long time. Think about it. Let's say this solid is at, why to say let's say, it is at 100 degrees Celsius and this liquid is at temperature, liquid is 20 degrees Celsius. It is very obvious that what will happen? Solid will lose its heat to liquid. And what will happen? After some time or long time, they will come in, they will be in thermal equilibrium. They will be in thermal equilibrium. Am I right or wrong? They will be in thermal equilibrium after some time. So how to find the final temperature? See, I can directly tell you the formula, but we can simply apply this approach. Let's say that after some time the final temperature is TF. TF is the final equilibrium temperature. Okay, so the approach that we are going to follow is heat lost by solid will be equal to heat gained by water. Okay, we are going to apply first law of thermodynamics to get the final temperature, equilibrium temperature. So this is mass of the solid into specific heat of the solid into 100 minus final temperature is equal to mass of the liquid into specific heat of the liquid into final temperature minus 20. Just put all the values, you will get the answer. Getting? Are you all getting this? So I'm just putting it here. This is mass of the solid is 10 into specific heat is 0.8, final temperature minus this is 100 is equal to mass, this is 40, specific heat is 4, final temperature minus 20. If you remember, there is also one concept. There is also one concept in that you have studied when you solve the question of CBT1, that if two liquids or one solid is getting mixed with liquid, then final temperature is specified by 0th law and obtained by first law. Remember that? So here what we are doing, we are applying the first law. Okay, clear? In this question they have given one thing to confuse you. They have given specific heat of water. It is not required because they have already given the specific heat. Solve it, you will get the answer. What answer you are getting? Tell me, what is the final temperature? What is the final temperature you are getting? Option D, 24. Are you all getting 24? Are you sure? Should I check or should I trust you? Let me check. Because again, if there will be some mistake, then students will write in the comment box, sir, this was some calculation mistake and I don't want to take risk. So the answer is 24. Yes. 24 degrees Celsius. Next, a single acting single cylinder reciprocating air compressor is compressing 20 kg per minute of air from 110 kilopascal and 300 Kelvin to 600 kilopascal according to this law. PV power 1.2 is equal to constant. This is the equation of a polytropic process. Remember? Here n is equal to 1.25. Mechanical efficiency is given as 80%. What is the power input to the compressor? How to solve this? How you will find the power input to the compressor? Now, let us consider that, and here it is written neglect clearance, leakage and cooling. What is clearance? They are asking to neglect the clearance volume. So when we neglect the clearance volume, in reciprocating compressor, neglect the clearance volume means, that means we are talking about ideal reciprocating compression. Okay, we are talking about ideal reciprocating compression. Okay, and what is the work input formula for ideal? For ideal reciprocating compressor, the formula is n by n minus 1, P1 into V1, P2 by P1, power n minus 1 by n minus 1. This is the formula. Now in this question, you can apply this as n by n minus 1. P1 V1 can be written as MRT1. P2 by P1 is, P2 is 600, P1 is 110. Power 1.25 minus 1 by 1.25 minus 1. See, 1.25 minus 1 is 0.25 by 1.25. What is this value? Do you know what is this value? This is 0.2. So this value, when you solve this, you will get this value as this value will be 1.4 directly. This is 1.4 minus 1, that is 0.4. Okay, so you will get work input as 1.25 by 1.25 minus 1 into, some of the students don't come in the class, sir, yes sir, बहुत question solve करा. तो भाई, what do you think in SSC JE CBT2 or RRB JE CBT2 you will get theory questions? Yeah, they will be theory question, but 40% will be numerical. I'm telling you, 20 by 60, because we want to answer in kilowatt, so this will be kg per second. Okay, mass flow rate into R will be 0.287. Okay, into temperature. What is temperature? Initial temperature is 300 Kelvin. Now, when you solve it, you will get this as 1.4 minus 1. Okay, this is directly 1.4. Okay, you will get the value of work from here. The work will be in kilowatt, but they have also given the mechanical efficiency. Is there anything to do with the mechanical efficiency here? Anything to do with the mechanical efficiency? What is the value of work you are getting? Let me also solve it. Otherwise, again, trusting you can be dangerous. It is coming out to be 57.4, but 57.4 kilowatt is coming, but because mechanical efficiency is 80%. So this is the work input you are getting, but mechanical efficiency is 80%, divide by 0.8. So you will get 71.75 kilowatt. So we have to take mechanical efficiency into consideration. Okay. All right. So the answer will come out to be option D. Because mechanical efficiency is given, so we have to divide by 0.8 to get the actual power input, 71.75 kilowatt. Next question. The coefficient of velocity for the steam turbine is a ratio of. Coefficient of velocity is equal to, it is the ratio of relative velocity leaving the blade to the velocity at the whirl, velocity of the whirl at the inlet of the blade, velocity of the whirl at the inlet of the moving blade to the relative velocity. What is the coefficient of velocity? The answer is option D. The coefficient of velocity is basically a constant which depends on the relative velocity at the exit of the blade to the relative velocity at the inlet of the moving blade. So the right answer is option D for this question. Okay, the coefficient of velocity can be denoted by K is equal to relative velocity at the exit to the relative velocity at the inlet. Okay, so this is called coefficient of velocity. All right. Next question. A throttle governed steam turbine develops 30 indicated horsepower by consuming 300 kg per hour of steam and 60 indicated horsepower with 570 kg per hour. How much steam is required to develop 20 indicated horsepower? In this question, they are giving the data about the steam turbine. For steam turbine, we follow a graph known as, it is a graph between the steam consumption and indicate power. This is called Williams line method. Okay, where this is A and this is B into IP. So mass of the steam consumption can be written as A plus B into IP. IP is the indicate power. In the first case, they have given that when the mass flow rate is 300 kg per hour, then the power is 30. In the second case, they are providing the data as 570 kg per hour when the power is 60. In the third case, they are asking what is the amount of steam developed when the power is 20 horsepower. So if you have to find the mass of the steam, A plus B into 20. If you know the value of A and B, you can get this answer. So how to get the value of A and B? Just solve these two equations. If you solve these two equations, you will get, if you solve this equation 2 minus equation 1, you will get 270 is equal to B into 30. So you will get B as 9. And if you put B as 9 in any of this, you will get A as, what is the value of A you are getting? Simple calculation. So if B is 9, this will be 9, 30, 270. So A will be 30. So A is 30, B is 9. Put the value, mass of the steam will be, A is 30 plus 9 into 20. That is 210 kg per hour. Okay, option A. Clear? Again, I have done the same mistake. I started to solve this question as soon as I saw this question. Next question. An electric generator coupled to a windmill produces an average electrical power of 6 kilowatt. The power is used to charge a storage battery. Heat transfer from the battery to the surrounding is 0.3 kilowatt. What will be the amount of energy stored in the battery in 2 hours? So basically we have a generator which is coupled to a windmill. Obviously the windmill will produce electrical output, or electrical energy is produced by the windmill, but that is basically produced with the help of a generator. Now whatever electricity is produced by the generator, that is stored in a battery. This battery is basically storing that electrical energy. How much electrical energy it's storing? That is 6 kilowatt. But also this battery is getting heated, so it will lose the heat. How much heat is it's losing? 0.3 kilowatt. Okay. Now they are asking what is the energy stored. What is the amount of energy stored means? They are asking the internal energy stored. What is the internal energy stored in 2 hours? Simple question. First law of thermodynamics, Q minus W is equal to du. Heat is the rejected heat, so this will be minus 0.3. Work is input, so it will be minus 6 is equal to du. If you solve it, you will get 5.7 kilowatt as the internal energy. Right? Now, 5.7 kilowatt is the internal energy, that is 5.7 kilojoule per second. That is basically stored in it. Now you need to simply convert that into kilojoule. How you will convert into kilojoule? Multiply with 2 hours. Now 2 hours have to be converted into seconds, so that will be 2 hours into 60 into 60. If you solve it, you will get 41040 kilojoule. Simple. Okay? Clear? Next question. In case of power failure, a battery is used to light a bulb, a fan. There is a power failure, obviously बात है power failure होते हैं. And then we have an inverter, and inverter we have a battery. So that battery is doing what? It is used to light a bulb, run a fan, and heat an electric iron. I don't know who is using an electric iron when there is no light. I don't use it. I think nobody does that. But each are having the power. Each are basically of how much power consumption is there. Light, see, a bulb is of 100 watt. Who uses 100 watt bulb now? That is history now. Now everyone try to save electricity. There we are using 5 watt, 10 watt maximum. But let's say fan is 100 watt fine, electric iron 100 fine, but bulb 100 watt. And they all are used for 10 minutes. Okay, it's good that only 10 minutes. So 10 minutes के लिए चलाया इनको. In this operation, the work done and the heat supplied by the battery. Acha. How to solve this question? First of all, the total electrical work, because the work will be electrical work, it will be 100 into 3, that is 300 watt. Because each of 100 watt, and there are three appliances: fan, iron and bulb. So total electricity consumption will be 300 watt. 300 watt means 300 joule per second. Okay, multiply with how much time it is used, 10 minutes, into 60, it will be 10 into 60 seconds. Solve it, will be 18 1 2 3 4 18 joule, that is equal to 180 kilojoule. This is the work input, electrical work input. Now work is equal to 180 kilojoule, that is for sure. Next thing is they are asking what work done and the heat supplied by the battery. Heat supplied by the battery. Why the battery will be supplying the heat? Because battery is basically giving you the we are using the battery. Battery is not going to supply any heat. So heat will be 0, but there will be electricity that will be used, will be work will be 180 kilojoule. There will be no heat supplied by the battery. Heat supplied by the battery will be 0 in this case. And generally battery is insulated. Battery is generally insulated, so that there should be no heat transfer from the battery. So this is heat will be 0 while the work will be 180 kilojoule. A gas is enclosed in a piston cylinder arrangement. The gas is initially at a pressure of 500 kilopascal and occupies a volume of 0.2 meter cube. The gas is taken to final state where the pressure is 100 kilopascal through a process in which volume of the gas is inversely proportional to pressure. See, this is the main thing. Through a process in which volume is inversely proportional to pressure. The work done by the gas is. How to solve this question? Volume is inversely proportional to pressure. So PV will be constant. Can we say this is a constant temperature process? Why not teach in board? See, this is basically a organization, kind of a startup by the ex-BYJU'S faculties, which was the earlier organization, which was shut due to less funds. They don't have fund, they just shut everything without thinking about the student, without thinking about the teachers. So the ex-BYJU'S faculties, they have started their own company, and you know what is the cost of a smart board? It will be around 3 lakhs or 2 lakhs. It's not possible to install a smart board for every faculty. So whatever kind of setup we have, we are providing that knowledge. Basically, the main idea is the knowledge transfer. Okay, so knowledge transfer is happening in this setup also. A smart board, that happens. It is just visual satisfaction that happens if you if a teacher is taking class from the smart board, right? All right, just see this question. Initially the initial pressure is equal to 500 kilopascal and volume of 0.2 meter cube. The final pressure is equal to 100 kilopascal. Because this is a relation that you get, we can simply say P1 V1 is equal to P2 V2. We can apply. From here you will get V2 will be equal to P1 is 500 into 0.25 divided by 100. So this will be, you will get the value of V2. V2 will be 1.25 meter cube. Now, because we know it is a constant temperature process, you can solve this question as simply P1 V1 log of V2 by V1 you can use, no problem. You can also use this equation, or you can use P1 by P2. Still you will get the answer. Solve it. Are you getting the answer or not? I have to also check it. Yeah, you were getting approximately 201, right? 201.1 kilojoule. Yeah, approximately you are getting this as the answer. Are you getting? Are you all getting this value? Just a second. Are you getting this value? 201. See, whether you apply V2 by V1 or P1 by P2, you will get the same value. Volume sir 0.2. अरे यार 0.2 है, कोई बात नहीं, 0.2 ले लो इसको. So what is the answer? अरे यार 0.2 है. This will be 1. Simple. Still, when you solve it, so this is also log 5. This is also log 5. Okay, whether you use P1 by P2 or V2 by V1. Okay, and this is same. So the answer will be 200. Next question. 160.9. Oh, sorry. I have not seen this 0.2. So this will be 160.9. Okay, by using 0.2, when we use 0.2, the answer will be 160 kilojoule. See, this question can be solved by one more approach. There is one more approach for solving this question. Should I tell you that approach, or are you happy with this approach? You want to know that approach also? This question can be solved by one more approach. And that approach is this. Whenever this type of relation comes in your exam, you can also plot a pressure volume diagram. And by that pressure volume diagram also you can solve this question. Simple. Initial pressure is 500. Initial volume is 0.2. Final pressure is 100. Final volume is 1. So simply you can say that this is an expansion process. Expansion process happening like this. An expansion process, you can simply say that the kind of area will be this area. You can simply find the area below this. If you find the area below this graph, you can get the answer. Or if you get this area, this is P1, this is P2, this is V1, this is V2. Okay, so you can find the area covered, and you will get the answer of work. But I think this is not the area. You have to find this area. That is area of trapezium. Area of trapezium will be equal to net work. Okay. Solve it, you will get the answer directly. I think you should get the same value. Okay, area of trapezium is equal to half of sum of parallel sides. These are the parallel sides, that is 500 plus 100 into this V2 minus V1, that is 1 minus 0.2. Okay, so solve it. This will be 300 into 0.8. I think you should get the same value, if I am not wrong. I think not. I think this approach is not applicable here. This approach is not applicable. No, 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 not applicable. This approach is not applicable. Okay, you can follow this approach only. Right. This is valid somewhere, but I don't remember exactly. For this question, you can follow this approach only, finding the isothermal work. I think there is some relation where this approach is valid. The approach where you can follow this approach where there can be some questions like this. I have seen this question. Maybe here this approach is not applicable, but I know that where this approach will be applicable. This approach is applicable where the pressure and volume are related as pressure and volume are linearly related, right? Then in that case, this approach is valid, like this. Okay, then this kind of curve will be there. The work will be equal to area of trapezium. Okay, then this linear relation of pressure volume can be plotted with the help of this kind of curve, and the area of this curve will give you the work. Okay, so this, it's not that this approach, like in the case of spring forces. Yes, correct. Because it is a case of isothermal, I think this is not applicable. It is a case of constant temperature process. It is applicable when pressure and volume are linearly related, like pressure is directly proportional to volume, or P is equal to constant into V, something like that. So whenever this kind of approach is there, then you will follow it. Next question, an insulated constant volume system containing 1.3 kg of air receives 53 kJ of pedal work. The initial temperature is 27 degrees Celsius. Determine the final temperature. It is an insulated constant volume system. Okay, constant volume system is there, so work will be 0, right? But which work will be 0? Boundary work will be 0, or closed system work will be 0, but there will be other work also. Constant volume system containing 53 kg of paddle wheel work. So paddle work is there, so work input is equal to minus 53 kilojoule. System is insulated, so heat transfer will be 0. Determine the final temperature. Now you know that if heat transfer 0, Q minus W is equal to du. If this is 0, then work will be equal to minus of du. So du will be equal to 53, right? So you can simply apply du is equal to 53. 53 is equal to mc delta T. From here you can apply this. 53 will be equal to mass. Mass is equal to 1.36 into C is, CV is, you can take 0.718. T2 minus T1, 27. Just solve it, you will get the answer. Hi Vikas, good evening. Yeah, after thermodynamics, FM will be started by me. In the month of October, I will be taking FM in that batch. That is already planned. Okay, Vikas. It is already planned. So you will get 81, final temperature will be 81.3 degrees Celsius. Okay, option C. Clear? Is it clear to everyone? This was the last question of today's session. I think I'm running, today I have some important work. I have to end the session at this point of time. I hope you all understood these all concepts. And let's solve this last question. In order to have a low bypass factor of the cooling coil, the fin spacing and the number of tubes row should be respectively. Let's take this as our last question. So my dear, what is bypass factor? Whenever we have a cooling coil or heating coil, we always find the bypass factor, contact factor, coil efficiency. So this is a coil. Bypass factor is definitely, bypass factor is means how much air has pass through coil without coming in contact, that is the meaning of bypass. Okay, so if you see, if you want to reduce the bypass factor, if you want that bypass factor should be low, we want that our bypass factor should be low. How it can be low? Now what you can do is fin spacing. If the spacing between the fin is very close like this, if you want to catch something, we have to decrease the fin spacing. The fin spacing should be close, not wide. Wide will not be. And number of tubes should be large, more tubes, high. So closely spaced and number of fins should be high. Then you can reduce the bypass factor. Okay, so that is the last question. Rest of the question we can take in the next session. Thank you so much. If you have not joined our YouTube channel yet, then I request everyone, please do subscribe to our YouTube channel and press the bell icon. And also you can share this session and like the session if you like the content. Thank you so much. Have a nice day. मैं आप लोगों से कल मिलूंगा. I'll see you tomorrow at 8 PM. Thank you everyone. See you tomorrow. Thank you so much.